நாளைக்கு நாளைக்கு போனோம் கட்டணம் பேசணும்
Can you hear me, Nandini R? Hello? Can you hear me? So we will wait for a few minutes more. Let some other students join if they are coming. Then after some time, so we will start. So please wait.
மியூட் எடுத்துட்டு பாரு ஆன் ஆகுது ஆஃப் பண்ணிடு
So can you see my screen? Hello, am I audible to you? Hello. So a good evening to all. I welcome you again to this international session on atomic and molecular physics for January 2024 session with course code NOC 24PX04, which is being flowed this uh, semester by NPTEL. So today is our seventh interaction session. Myself, Vivekananda Naik. I am a PhD research scholar at the Department of Energy Science and Engineering, IIT Delhi. So we will discuss a few questions which will be based on the week 7 contents of the course. So let's start our discussion. Now, the question number one. The question says an atom having electron configuration 1s to 2s to 2p1, then find the torn symbol of its ground state. Options are option A 2p half, option B 2p 3 by 2, option C 2d half, and option D 2s half. So the question says an atom is having electron configuration of 1s to 2s to 2p1. So if you see, if this is the configuration, then this is 1s, this is 2s. 1s, 2s, 2p. So 1s 2 means there are 2 electrons, 2s means there are 2 electrons, and 2p1 means there is only single haploid electron. So we need to find the torn symbol for the ground state of this atom. So can you tell me what will be the correct answer? So I'll give you a few minutes to try this. So please try and tell me what will be the correct answer. Then I will discuss. So yes, can you tell me what will be the correct option? So you see, if you look at the electronic configuration, then both these cells, 1s is completely filled and 2s is completely filled, because we know the S subcell can accommodate only 2 electrons, and in this case, S subcell contains those 2 electrons. So the last electron, which will determine the term symbols or the spectroscopic terms for this particular atom, will be this 2p subcell. So if you see for P, what we have for P subcell, we have L equal to 1. So for P subcell, we have L equal to 1. And since there is a single electron, so for the single electron, S will be half. So these are the two values, L and S. So since there is only a single electron, so we can write it small l as capital L and small s as capital S. Now, according to the LS coupling, J is L plus S to L minus S mod with one increment with difference of 1. If you see here, there is, since S is half, so there will be only two combinations, 1 plus half and 1 minus half. So 1 plus half, 1 minus half. 1 plus half is 3 by 2, 1 minus half is half. So we have, these are the J values. So now we have J values half and 3 by 2. L is 2, S is half. So if you write the spectroscopic notations, it will be 2s plus 1 Lj. So S half means it will be 2s plus 1 will be 2. So it will be 2. L is P. Sorry, L is not 2, L is 1. L is 1. So 2P. Then we have P half and P 3 by 2. So these are basically, this is a doublet state, which is 2P half and 2P 3 by 2. So this is the term which will arise due to this electron configuration. But the question says find the torque symbol of its ground state. So if we talk about ground state, we know the spectroscopic terms or the energy levels that comes out of the coupling between the spin and orbital angular momentum. And these levels are arranged in increasing order of their energies according to Hund's rule. And if we talk about Hund's rule, there are different rules uh, according to which the levels are arranged. For example, if the multiplicities, so with respect to the multiplicity, with respect to the L values, and with respect to J values, labels are arranged differently. So if you see here, now we have these two values, and for both the labels, L and S are same, but J are different. So out of these two, only one will be the ground state or the lowest energy state. So what Hund's rule say? There is, so since both have same L and S value, but a different J value. So for this condition, according to the Hund's rule, what Hund's rule says? Hund's rule says if a orbital is less than half filled, then L minus S value will be the lowest state or ground state. But if the orbital is more than half filled, then in that case, L plus S will be equal to J for ground state. So here you can see for P, we know P can accommodate 6 electrons. So half filled means 3 electrons, but here you see it is less than half filled. So for less than half filled, according to the Hund's rule, For less than half field, the J value for ground state will be L minus S. So here you see L minus S is half, L plus S is 3 by 2. So the lowest energy level or the lowest state, which is the ground state, will be 2p half. That is, which have lowest J value. So the correct option will be option A. Is this clear to everyone? Yes? Is this clear to both of you? Hello? Am I audible to you? Okay, so if you don't have any doubt in this question, so let's go to the next question. And the question says, express the following state in spectroscopic notations. L is 1 and S is half. So options are option A, 2p half 3 by 2. Option B, 2d half 3 by 2. Option C, 2s half 3 by 2. And option D, 3p half 3 by 2. So yes, can anyone tell me what will be the correct expression for the correct spectroscopy notation of the state which have L equal to 1 and S equal to half? Yes. So we have just in the previous question we discussed the same case. So if L equals to 1 and S equals to half, then LS coupling, according to the rules of LS coupling, J will be L minus S mod up to L plus S with one increment, which is the vector addition. So J will be 1 plus minus half, that is 1 minus half and 1 plus half, which is half and 3 by 2. So for L equals to 1, it will P. S equals to half means 2S plus 1 is half into 2 plus 1, which is equals to 2. J is half and 3 by 2. So the spectroscopic term is 2p half and 3 by 2. So the correct option is option A again. So now let's talk about the other three options like option B. Option B, we have 2d half and 3 by 2. 2d half 3 by 2. So can anyone tell me, is this a correct or is this a feasible state? Whether this type of state is possible? Can anyone tell me whether this type of this type of states are possible or not? See here it is D. So D means L is 2 and 2S plus 1 is 2 means S is half. So according to LS coupling, J is L plus S to L minus S It will be 2 plus half and 2 minus half. So it is 5 by 2 and 3 by 2. So if th- there is a if there the multiplicity is 2 and the orbital is d, so the resulting j values will be 5 by 2 and 3 by 2. So this state is not possible. Anyway, this was not the correct option, and also if you check, this states is not possible. So this state is not possible. Now again talk about the same thing. 2p, 2f half and 3 by 2. So now talking about option C, 2s half and 3 by 2. For 2f half, L is equal to 3 because S, P, D, F 0, 1, 2, 3. So L equal to 3 and S equal to again half because 2s plus 1 is 2. Then J values will be 3 minus half and 3 plus half. So it will be 7 by 2 and 5 by 2. So if it is F, the correct representation would have 7 by 2 and 5 by 2. So this is correct. This is wrong. So again, this option is also wrong. Now here it is wrong obviously because you see here it is 3. 3 means that there are 3 states with same value of L and J. But here if you see there are only 2 states given. So now if you see, let's talk about the fourth option. For P, L equals to 1 and S equals to 1 because multiplicity is 3. So J will be 1 plus 1 to 1 minus 1. Then it will be 2, 0, then 1. So 2, 1, 0, 1, 2. There will be 3 values. So it will be 3P, 0, 1, 2. So this should be the correct representation. But here, so if you see out of these 4 options, the remaining 3 are also not feasible. This type of states does not exist in the feasible world because they violate the LS coupling and their representations. So is this clear to everyone? Okay, so I hope you understand these things. Then go to the third question. So the question says, find the values of L, S, J and the multiplicity for the given spectral level 3D2. It is 3D2. This is the level. I'll give you a few minutes. So please try to solve these questions because the main intention of this interaction session is to interact with your interact with my interact with me. So you should interact with me. If you have any queries, any doubts, you can ask me. So I'll give you a few minutes to try this. Then we will discuss. So yes, can anyone tell me what will be the correct option? Option A, B, C or D? Yes, so if you see, the question says find the values of L, S, J and the multiplicity for the given spectral level 3D2. So for 3D2, the multiplicity is 3. So it is 2s plus 1 equals to 3, which gives s equals to 1. Again, so this 3 is nothing but the multiplicity. Then s equal to 1. For D, L equals to 2 and J, this is nothing but J, so J is equals to 2. So if you compare it with the spectros notation 2s plus 1, Lj, you will find s equals to 1, L equals to 2, J equals to 2, and the multiplicity is 3. So the correct option will be L 2, 1, 2, 3. So this will be the correct option, option B. Then, is this clear to you? Okay, so let's go to the next question. Now, if we again in this question, if we talk about other options, now 0, 0, 0, 1. So can anyone tell me what will be the state which consists of L0, S0, J0 and multiplicity 1? What will be the state? L is 0, S is 0, J is 0 and multiplicity 1. So what will be the term? You see, L0 means it is S, S0 means 2s plus 1 will be 1 only, which is again the multiplicity. So it will be 1s and then J0. So the term will be 1s0. So this is the term, and this type of term, that is 1s0, arises when the state is completely filled. Like if it is for S, if it is completely filled, then it will give 1s0. For P, if it is again completely filled, it will give 1s0. And for D, so this is D10, S2, P6. So this type of electronic configurations which are completely filled, they give rise to this term 1s0. Like here it is again 4, 3, 2, 1. 4 means L is 4. L4 means it is G. Then S is 3. S3 means, you see here it is S3. So 2s plus 1 will be 2 into 3 plus 1, which will be 7. But here the multiplicity is 1. So this is not possible. So similarly, if you talk about this option D, again this will be not possible. Because here the multiplicity is 4. Now, if you talk about multiplicity is 4 means 2s plus 1 is 4. So S is 3 by 2 and L is given as 1. L is 1. So it will be 1 plus 3 by 2, 1 minus 3 by 2 mod. So it will be 5 by 2 and half. These are the values of J. But here if you see here L is here S is, so this is one type of combination. So S is 3 by 2, L is 2, J is 5 by 2, I think. Yes, J is 5 by 2 and S is 4. Sorry, multiplicity is 4. So this type of term will be 4D 5 by 2. So this will be the spectroscopic term corresponding to option D. So this is clear to all of you. Then the next question, question 4. Question 4 is the term for a particular atomic state is 4D 5 by 2. What are the values of L, S and J? What is the minimum number of electrons which could give rise to this state? The options are option A 3, 2, 1, 4. That is L is 3, S is 2, J is 1 and multiplicity is 4. Then option B is 4, 3 by 2, 1, 3. Option C is 2, 3 by 2, 5 by 2, 3. And option D is 1 by 2, 3 by 2, 5 by 2 and 7. So I'll give you a few minutes to try this question. And remember the question says, what are the value of L, S and J? And again the fourth question in this question is, what is the minimum number of electrons which could give rise to this state? So now 45 by 2, 45 by 2 is the spectroscopy term of a electron configuration. So what should be the minimum number of electron in that state? If they are present, it can give rise to the spectroscopy term which is 45 by 2. So we have to determine that. Please try this. After some time we will discuss. So yes, did anyone solve it? What will be the values of L, S, and J, and what is the minimum number of electrons which could give rise to this state? So if you see for 4d5,
Yeah.
So I'm extremely sorry for the inconvenience. There was some unavoidable situations on my end, due to which I was offline for some time. So yes, so you will now see the torn for a particular atomic state is 45/2. What are the values of L, S, and J? And what is the minimum number of kilotons which could give rise to this state? So if you see 4D 5/2. So this 4 is 2s plus 1 equal to 4, which gives s equal to 3/2. So s is 3/2. For D, L is 2, and here J is 5/2 given. So this 3 is clear, 3/2. So L is 2, S is 3/2, and J is 5/2. So 2, 3/2, 5/2. We can clearly say this will be the correct option. And then the question is, what is the minimum number of electrons which could give rise to this state? So now if you see here, S is 3/2. So if you have S is equal to 3/2, and for one electron, S is half. So how many electrons do you need to get S is equal to 3/2? It is 1/2 plus 1/2 plus 1/2. So there are three electrons we need so that S will be 3/2. So the minimum number of electron which could give rise to this state is 3. So here the 3 is also present. So the correct option is option C. I hope this is clear to you. Then question number 5. Calculate the angle between L vector and S vectors for the torn 2D 5/2. Option A is 41.9 degree, option B is 51.9 degree, option C is 61.9 degree, and option D is 71.9 degree. So in the previous class, we had discussed how we will calculate the angle between L vector and S vector. So I request you to please try this question, and after a few minutes, we will discuss what will be the correct answer. Yes, can anyone tell me how we will calculate the angle between L vector and S vector? So now see here the expression, how the expression comes. We know J is equals to L plus S. So J vector dot J vector will be L plus S dot L plus S, and then it will be L square S square plus 2 L vector dot S vector. So this will be Z dot J square. So J square minus L square minus S square by 2 will be 2 L vector dot S vector. So it will be 2 LS cos LS will be J square minus L square minus S square by 2. So the angle cos theta, which is angle between L vector and S vector, is J square minus L square minus S square by 2 LS. And in quantum mechanics, if you remember, these J vector have the values J into J plus 1 root over. So J square is J into J plus 1. L square is L into L plus 1. S square is S into S plus 1. So the expression for angle is J into J plus 1 minus L into L plus 1 minus S into S plus 1 divided by 2 L into L plus 1 root over S into S plus 1 root over. So now the question says the state is 2D 5 by 2. So for 2D 5 by 2, if you see 2S plus 1 equals to 2, which gives S equals to half, J equals to 5 by 2, and D means L equals to 2. So we have these three values, L, S, and J. So if you put these values, then cos theta will be 5 by 2 into 5 by 2 plus 1 minus 2 into 2 plus 1 minus half into half plus 1 divided by 2 into 2 plus 1 root over 2 into 2 plus 1 root over half into half plus 1 root over. If you solve it, you will get 0.4714. So cos theta is 0.4714. Theta is cos inverse 0.4714, which is 61.9 degree. So the correct option will be option C, 61.9 degree. Is this clear to you? Yes. Is this clear to you, Nandini? Can you hear me? Anyway, you are not responding. So you will go to the next question. The question says, find the J values for the given state L equal to 2 and S equal to half. So for L equals to 2 and S equals to half, we need to find the value of J. So the options are option A is 5 by 2, 3 by 2. Option B is 5 by 2, 3 by 2 half. Option C is 5 by 2, 3 by 2, 1 by 2, minus 3 by 2. And option D is 3 by 2 half and minus 3 by 2. So can you tell me what will be the correct option? Yes, can you tell me what will be the correct option? Yes, can you tell me? So you see, it is very simple question. J will be L plus S to L minus S magnitude. So L plus S is 2 plus half and then 2 minus half. 2 plus half is 5 by 2 and 2 minus half is 3 by 2. So the correct option will be option A, 5 by 2 and 3 by 2. Then question 7. Find the values of L vector dot S vector when L equal to 1 and S equals to half. Options are option A minus S square and x square by 2. Option B is minus 3 by 2 square square by 5. Option C is 3 by 2 square minus 7 square by 2. And option D is 5 by 2 square minus 5 square by 2. So these are the four options. I request you to please calculate and tell me what will be the correct option. So yes, can you tell me what will be the values of L vector and S vector on L equal to 1 and S equals to half? Yes, can you tell me? So if you see here, L and S are given and there is two values of L dot S. So how the two values will come? So one value will be for J equals to L plus S, another value will be J equal to L minus S. So for L equals to 1, S equals to half, we have J equals to 1 plus half and 1 minus half. 1 plus half is 3 by 2, 1 minus half is half. So J equals to 3 by 2, there will be one value, and J equals to half, there will be second value. Now what are the values? I just told you that L vector is given as L into L plus 1 root over H cross in quantum mechanics. Similarly, S vector is S into S plus 1 root over H cross. And if you see, then the expression for L vector dot S vector will be like we have discussed in the previous question, J into J plus 1 minus L into L plus 1 minus S into S plus 1 divided by 2 into H cross square, because this H cross square will be, since L and S are being multiplied, H cross will give us H cross square. Now if we put all these values, like we have J equals to 3 by 2, L equals to 1 and S equals to half. If you put these values, it will give half into half plus 1 minus 1 into 1 plus 1 minus half into half plus 1 divided by 2 h cross square, which will give us minus h cross square. This is one value. Then the second value will be for j equals to 3 by 2. So this is j. This value is for j equals to half. Then for j equal to 3 by 2, L vector, S vector will be 3 by 2 into 3 by 2 plus 1, 1 into 1 plus 1 minus half into half plus 1 divided by 2 into h cross square. Sorry, let me. So this will be h cross square here. So if you put all these values, it will give you L vector dot S vector equals to half h cross square. So the answers are minus h cross square and half h cross square. So the correct option is minus h cross square and half h cross square. So option A will be the correct option. Is this clear to you? Okay, so let's go to the next question. The question says find out the value of landed G factor for the level for the half. Option A is option A is 3, option B is 2, option C is 1, and option D is 0. So we have discussed in the previous sections also. So how to find out the values of landed G factor. So we can use the formula and calculate the values of landed G factor for a particular label, because this particular label has value of L, S, and J. So I request you to try this question, and after some time we will discuss. So yes, did you calculate? So if you see for this given level, which is 4D half, what we have for 4D half level, we have 4 equal to 2s plus 1, which gives s equals to 3 by 2. D means L equals to 2 and J is half. So these are the values for this particular level. And if we talk about the expression for landed G factor, it is given by G equals to 1 plus J into J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2J into J plus 1. So putting the value 1 plus half into half plus 1 plus 3 by 2 into 3 by 2 plus 1 minus 2 into 2 plus 1 divided by 2 into half into half plus 1. So if we calculate, it will be 1 plus 3 by 4 plus 15 by 4 minus 6 divided by 3 by 2, which will give 1 plus minus 6 by 4 divided by 3 by 2 will be 1 minus 1, which will be 0. So G is 0 for this particular level. So the correct option will be option D. So is this clear to you? Okay, so let's go to the next question. The question says, write the spectral symbol with S equals to half, J equals to 5 by 2 and G equals to 6 by 7. Now, the options are option A, 2p 5 by 2, option B, 2d 5 by 2, option C, 2s 5 by 2, and option D, 2s 0. So can you tell me how we can find out the spectral symbol? So if you see here, S, J and S, J is given and G is again given. But in order to write the spectral symbol, we need the value of L. What will be the value of L? So from the value of G, we can extract or derive the value of L. So if you use the formula of G in the previous question as we discussed, so using that formula, we can easily calculate the value of L. And since S, J value is given, when you know the value of L, we can easily write the spectroscopic notation of the given term. So please try this question, and after some time we will solve and find out the correct answer. So if you see the previous question, we wrote the expression for G, and according to this expression, G will be 1 plus J into J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2 J into J plus 1. So you will use the formula, but we will put the values of S and J because we don't know the values of L. It will be 5 by 2 into 5 by 2 plus 1 plus half into half plus 1 divided by 2 into 5 by 2 into 5 by 2 plus 1 minus L into L plus 1 again divided by 2 into 5 by 2 5 by 2 plus 1. So it will be 1 plus 35 by 4 plus 3 by 4 divided by 35 by 2 minus L into L plus 1 divided by 35 by 2. Then L into L plus 1 will be L into L plus 1 divided by 35 by 2 will be 35 by 4 plus 3 by 4 is 38. So it will be 1 plus this is uh, this second, this is in the left hand side, it is 6 by 7. So it is 1 plus 19 by 35 minus 6 by 7. Then L into L plus 1 will be 24 by 35 into 35 by 2, which is 12. So L is how much? If you see, L square plus L is 12, or if simply you can easily say L is 3 because L plus 1 will be then 4 and L into L plus 1 will be 12. So L is 3. So we got L is 3, S is half already given, and J is 5 by 2. So if, since S is half, 2S plus 1 will be 2. So the term arising from it will be how? It will be 2. L is 3 means D, and G is 5 by 2. J is 5 by 2. So it will be 2D 5 by 2. Sorry, L is 3. So S, P, D, F. So it will be F. So the correct option will be 2F 5 by 2, which is option C. This will be the correct option. Then question number 10. Question number 10 says, find out the de Broglie wavelength of an electron in the ground state of the hydrogen atom. Consider the energy of the electron in the ground state of hydrogen atom is 13.6 electron volt, and Planck's constant is h cross h, which is 6.626 into 10 to the minus 34 joule into second. So I'll give you a few minutes to try this. Then after some time, we will discuss how we can calculate the wavelength, de Broglie wavelength given the current scenarios. So yes, can you tell me what is the correct option? So now if you see, the question says find out the de Broglie wavelength of an electron in the ground state of hydrogen atom, and we know the ground state energy of hydrogen atom is 13.6 electron volt, and the de Broglie wavelength corresponding to a particular particle given by, according to the expression, is lambda equals to h by p. So now this p, we have the energy in electron volt. So now this p can be converted. We know the energy is given by p square by 2m. So p will be nothing but 2me root over. So, but the energy here is given in terms of electron volt. So 1 electron volt is 1.6 × 10 minus 19 joule. So we will convert it to joule, and then we will calculate. So lambda will be h by 2me root over. So h is 6.626 into 10 to the power minus 34 divided by 2 into, here m will be what? Mass of electron, because here we are calculating the de Broglie wavelength of the electron. So it will be 9.1 into 10 to the power minus 31 kg into energy E. It will be 13.6 into 1.6 into 10 to the power minus 19, because 1 electron volt is 1.6 10 to the power minus 19 joule. So if you take the root over, then it will give lambda will be 3.33 into 10 to the power minus 10 meter, which is 3.33 angstrom. So the correct option is option C. So according to de Broglie's principle, each particle is associated with a wave, and the wavelength is given by lambda is equal to h by p, where p is the momentum and h is the Planck's constant. We know the value of Planck constant, that is already given in the question. Now the expression, now the additional information we have is the energy of the electron in the ground state of hydrogen atom, and that energy is 13.6 electron volt. Now if you see, the energy needs to be converted into joule. So we know 1 electron volt is 1.6 into 10 to the power minus 19 joule, and the relationship between momentum and energy is p square is equal to 2me. So p will be root over of 2me. Now putting all the values, if you calculate, lambda will be h by 2me root over, which will give us the value of the wavelength is 3.33 angstrom. So if the electron is present in the ground state of the hydrogen atom, which have which has the energy 13.6 electron volt, then the wavelength associated with that electron will be 3.33 angstrom. I hope this is clear to you. Now let's discuss some few questions that I have prepared. This was not in the previous year sample questions. Now suppose the question is, there is a 2D potential well. So the 2D potential well is like, so the potential is a function of 2D means two dimensional, so it is a function of x and as well as y. So the potential is 0 for x minus a to a and y minus a to a, and is infinite otherwise. So the potential, suppose this is a two-dimensional space. So in a suppose y is equal to minus, suppose this is the 0, then here it will be x minus x, y minus y. So in this region, the potential is 0, but outside this region, the potential is infinite. So this is basically an example of a two-dimensional wave. So now we are seeing this type of potential from the top, and from the side, if you see, it will be somewhat like this. So from minus A to A, it is 0, and the remaining part of the potential is infinite. Now we need to find out the energy of this potential. What energy? The fast excited state energy. So what will be the fast excited state energy of this particular type of well? So the options are pi square h cross square by m a square, 2 pi square h cross square by m a square. Option 3 is 5 pi square h cross square by 8 m a square, and option D is 4 pi square h cross square by m a square. So now understand the question properly. This is a two-dimensional potential well, and this is the the form of the potential, and we need to find the fast excited state energy of this potential, not the ground state, the fast excited state. So these are the options. So I will give you some times to calculate it, and after some time we will discuss what will be the exact fast excited state energy of this particular two-dimensional potential well. So yes, can you tell me? So if you remember the one-dimensional potential well, so in one-dimensional potential well, what happens? In one-dimensional potential well, now if the length of the potential is A only, suppose A is the length of the potential, the energy is given by n square pi square h cross square by 2m a square, where n stands for the levels. So now here if you see, x ranges from minus a to a, so it is 2a. So E will be pi square h cross square by 2m into 2a square and n square for one dimension. But for two dimensional, what will happen? Energy will be nx square plus ny square, then pi square h cross square by 2m. 2a square means 4a square. Now you see, we know the minimum value of nx and ny is 1 for two-dimensional potential well. So now putting the values, what will be the energy value? Initial value of energy will be 2 pi square h cross square by 8 ma square. 8 ma square. So this is the ground state energy. Now the question, according to the question, we need to find out the fast excited state energy. So how we will find out the fast excited state energy? Now we know the values of nx is 1, 2, 3 up to, then the value of y is 1, 2, 3. So you see the minimum possible energy is nx is equal to 1 and ny is equal to 1. So the next or the fast excited state will be corresponding to nx is equals to 1 and ny is equals to 2. Or we can say that nx is equal to 2 and ny is equal to 1. But in both the cases, you see nx square plus ny square will be 1 square plus 2 square will be 5. So for both the cases, E will be same. So the resultant energy of this configuration will be the fast excited state. Then what will the fast excited energy? So the fast excited state energy will be 5 into the ground state energy, 5 into this I square h cross square by 8 ma square. So this is the correct value of the energy. So the correct option will be 5 pi square h cross square divided by 8 ma square. So is this clear to you? So what we did basically, the question was there is a 2D potential well and the 2D potential well is of length 2a because x varies from -a to +a and y also varies from -a to +a. So what will be the fast excited state energy of this potential? Then these are the options. Now according to one-dimensional potential well, if the length of the potential is a, then the energy is given by n square pi square h square by 2m a square. But here the potential is of length 2a, so it will be n square pi square h square by 2m into 2a square. Similarly, if you talk about the two-dimensional potential well, energy will be nx square plus ny square into pi square h square by 2m into 2a square is 4a square, and the values of nx and ny will be starting from 1. So nx is 1, 2, 1, 2, 3 up to many large values, and ny is also 1, 2, 3 up to number of levels. So we know the energy level, the ground state energy is 1, nx is equal to 1 and ny equal to 1. So the fast excited energy will be nx equal to 1 and ny equal to 2. So that the sum of nx and ny, so the sum of nx and ny will be 1 square plus 2 square equals to 5. You see, the next higher state which will be having the energy will be corresponding to nx equal to 1 and ny equal to 2, or nx equal to 1 and ny equal to 1. So this is a degenerate state and the degeneration is 2. So there are two states. There are two states which have the same value of energy, that is 5 into pi square h square by 8 ma square. So the correct option will be option third I, that is 5 pi square h square by 8 ma square. I hope this is clear to you. So we will end the session here today. In the next session, we will discuss some more problems which will be based on week 8 of the NPTEL course, Atomic and Molecular Physics. So till then, have a good day.